Hey guys, Mr. Mackey here, and welcome to the first episode of our new weekly themes. This week is entirely for students who go to secondary school, who need a bit of extra revision, because I've not really done many secondary school activities in this video. Now, if you go to primary school, I'm not saying don't watch these videos, because it's always good to be prepared so you know what you're in for. But you won't need to know what I'm going to be teaching this whole week for your SATs. But if you want to have a bit of practice, go ahead, join in, have some fun. But this is just for you who are about to start your GCSEs. Now, this week is entirely known as Triangle Week. And I'm going to be focusing a lot on loads of different things we need to do about triangles. Now, there are 4 types of triangles out there. Can anyone name what any of these 4 triangles are? Pause the video, think about it, then I'll go over it. I think I've given you enough time. So, this triangle here doesn't look anything special. This triangle has 3 lines, this triangle has 2 lines, this one has a little box inside it. So, what we're going to focus on firstly is this triangle, the 3 lines. Those 3 lines tell us that these sides and these angles are all equal, which is kind of helpful because this triangle is called an equilateral triangle. An equilateral triangle. Equilateral triangle is a triangle where all the sides and all the angles are the same. So if this side is 5 centimeters, this will be 5, this will be 5, and this angle 60, this will be 60, and this will be 60. It's an equilateral triangle. Now this one, only 2 of the sides are the same because there's only 2 of these little lines. Now that's not called a duolateral, a duo. I can't improvise. This is known as an isosceles triangle. This means that only 2 of the sides and 2 of the angles are the same. So not all 3. Now this one doesn't have any of these weird lines. So that means that none of the angles and none of the sides will be the same. This is known as a scalene triangle. Scalene. So none of the angles and none of the sides are the same. Now this final one is very similar to a scalene triangle. But what does that box mean? Well, we'll be focusing on angles later on in future videos. But that box means that this triangle has a right angle. So it's just simply a right-angled triangle. A right-angled triangle. And those are the 4 different types of triangles. Now, for the first 4 videos this week, I'm only going to be focusing on this triangle here. We'll get to these 3 later on. But it's good to remember what they are because you will need them for when I go on Friday, Saturday and Sunday. But for now, let's just focus on a right-angled triangle. Now, right-angled triangles are really special because you can do a lot with them. Now, these 3 sides actually all have names. They all have names. Let me show you. This long side here is known as the hypotenuse. The hypotenuse. That's what the really long side is. The hypotenuse will always be longer than this side or this side. If this side is shorter than either of those, you've not drawn your triangle right. This has to be longer. Now this side is opposite to the hypotenuse. So it's known as an opposite side. Now this side, okay, is quite next to the hypotenuse. So this is known as adjacent to the hypotenuse. So we have a right-angled triangle with an opposite, adjacent hypotenuse. The reason why I'm telling you this is you'll need to know this for the 4 lessons we're going to be doing this week. Now the first thing we're going to be doing is finding the sides of these triangles. How to find the sides, but only if we have 2 sides. If we don't know what any of the angles are, apart from that one, right angle, 90 degrees, spoiler alert for ahead. What if we only have these 2 sides? How could we find the hypotenuse? What if we have these 2 sides? How can we find the adjacent? Now, luckily, this person, about 2,000 years ago, came up with the idea on how to find these sides. His name was Pythagoras, and he came up with a theorem on how to find the missing sides. Now, I'm just not going to tell you this theorem. I'm going to show you what Pythagoras did. And for this, we're going to go back down into the creative room. Keep notes on what these triangle sides are called, because you're going to need them for later on the week. But now, let's go down. See you there. Welcome back to the creative room. It's been such a while since I've been in here. Let's get cracking on what we're going to be doing. We're going to be drawing our own right angle triangle to show you what Pythagoras came up with. Now, to do this, we're going to need three things. Firstly, a pencil. Pencils are always useful. People say, why can't I just use a pen? Well, let's face it, whenever you're drawing triangles, you could make a mistake. Pencils you can rub out, pens you can't. It will look messy, and I don't like mess much. So that's number one. The second thing you'll need is some squared paper. The reason why it's squared is because it's easier to draw the triangle that I have in mind on this squared bit of paper. I'm sure there's some lying about in your house. If not, ask your parents. There will be some squared paper lying about. If not, you could also use your exercise books, because maths books always usually have squared paper. The final thing you'll need is this. It's like a ruler, but it's known as a tri-square. It's shaped like a triangle. The reason why you'll know in a minute, it will help us draw this triangle a lot with this. You can use a ruler. I'll be using this because it's easier to draw with this, but if you can use a ruler, it just might be likely you might make a mistake, and in that case, use a pencil, definitely. So, I'm going to go to the creator, I'm going to go over here, and we're going to start drawing this triangle, and I'm going to show you what Pythagoras found. Right, so the first thing I want you to do is draw the bottom of this triangle, the base, which is the opposite. And how I want you to do that is I want you to make sure it is 12 squares long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. Now the next thing is I need you to draw the height of the triangle, the adjacent, and I need you to make this 5 squares big. 1, 2, 3, 4, 5. Now once you've done this, join them together and you will make the hypotenuse. Now, the base of this triangle is 12, the height is 5, and you will count from the number of squares long the hypotenuse is. It will be 13 squares long. Now, once you've done this, we are going to create squares underneath each of the sides. Let me show you what I mean. So, if the length of this side is 12, we need to draw 12 squares down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we draw 12 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then draw up. And you would have created your very own square. Now you do it to this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, this is the part of why we need this, because we're going to draw a 13 square tall square. But it would be much easier if we had this, because we can get it exactly looking like a square. But the question is, how do we know how big the square is? We know it's 13 squares across, but we're not going to go through some whole squares. How do we know how long it is? Well, that's what this ruler is actually for. Because when we line it up, we will see that it's about 65 millimeters long. So when we draw them, we line it up and we draw it so it is exactly 65 millimeters long. So let's go 1, 2, 3, 4, 5, 6, 65. Now let's do it the other side. And now join it together. And you've created 3 squares. Awesome. Now, the question I have is, how many squares are in each of the ones. How many little squares are there? So for this, we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are 25 little squares in here. What about in this one? 1, 2, 3, 4, 5. So once you've counted them all, you would have counted 144 squares here. So now, what about how many squares are in this one? This will be the hardest. If there's half squares, you find another half square, put that together, and that will make a whole square. So, count them now. And once you've done all these squares, you would have counted 169. That also includes if you have half squares and you put two of them together. If you have little quarter squares and a 3/4 square, you put them together. There will be 169 complete squares in this. So the question I have for you is, what can you notice about what we have just done? Well, one thing you can say is because this side was 5 and the total number of squares was 25, that 25 is the same as 5 squared, which could also be the same for 144, which is that side squared, and then 169, which is the hypotenuse squared. That is one thing you could notice. Fantastic. Awesome work if you notice that. What else can you notice from this? If that is 25, that's 144, and that's 169, what can you notice? I'll give you a clue. Think about adding. If you said that 25 plus 144, which are those two squares, equals 169, which is this side, you would be bang on right. So, what you have just identified from that is what Pythagoras identified when creating his theorem. So here is your challenge for tonight. What, in your own words, is the theorem? From what you have just found, when you found that 25 plus 144 gets us 169, can you figure out what the theorem that Pythagoras created was? And how can that help us find the missing sides of right-angled triangles? It's a lot to think about, sure, because I wanted you to try and work it out. I want you to discover it for yourself. Good luck. And let's bring on the rest of Triangle Week.